In this video, we are basically looking at the introduction to differential equations. We would consider the various orders of a differential equation and as well the formation of a differential equation. Alright, a differential equation shows a relationship between an independent variable x and a dependent variable y and one or more derivatives with respect to x. Example of a differential equation is this. Alright, we have an example of a differential equation is of such. Alright, we have another one. Okay, this is an example of a differential equation. We have a dependent variable y. We as well have an independent variable x. And then we have one or more derivatives with respect to x. This is a derivative with respect to x. Okay, and in this second equation, alright, we have an independent variable x. We as well have a dependent variable y. And we have one or more derivatives with respect to x. This is a derivative with respect to x, and this is a derivative as well with respect to x. Alright, that is pretty much about the concept of a differential equation. We have an independent variable x, a dependent variable y, alright, and one or more derivatives with respect to x. Okay, looking at the order of a differential equation, the differential equation can have the first order, it can have the second order, it can have the third order. Okay, this is determined by the highest derivative that is involved in a differential equation. In this first equation here, we have a differential equation of the first order. Alright, that is ORD. Okay, we have a differential equation of the first order. This is so because the highest derivative in this first equation is 1. Alright, we have dy dx. In this second equation, we have an equation of the second order. It is so because the highest derivative in the second equation is 2. Alright, we have the squared y over dx squared. Alright, we also have this, the squared y over dx squared plus 2 dy dx plus 10y equal to sine 2x. Alright, this is an equation of, guess it, of the second order. It's actually of the second order. This is so because the highest derivative is of the second order. The highest derivative in this equation is 2. Alright, I'm looking at the formation of a differential equation. Basically, we form a differential equation by eliminating the constants involved in that differential equation. Alright, so if we have y is equal to a sine x plus b cos x, alright, and we want to form the differential equation of this trigonometric equation. How we do that is by taking the derivative of this equation by the number of constants involved in this question. Alright, in this equation we have two constants, we have a and b. So we are going to take the derivative of this equation twice. Okay, if we have more than two constants in an equation and we want to form the differential equation of that equation, alright, we have to take the derivative of that equation based on the number of constants involved. Alright, if we have one constant, we take the derivative of that equation once. If we have two constants, we take the derivative of that equation twice. Alright, so in this part of the video, we are going to look at formation of a differential equation. Okay, let's go ahead and form the differential equation of this trigonometric equation. If we take the derivative of this equation, we would have that dy dx is equal to The derivative of sine x is cos x, a cos x. The derivative of cos x is minus sine x, is minus sine x. Alright, then we would have to take the second derivative of this equation, d squared y over dx squared is equal to minus a sine x, alright, minus b cos x. Okay, if you notice, we can factor out a negative from this equation. If we should do that, we would have minus a sine x plus b cos x. Alright, if you would agree with me, this is equivalent to this. Alright, so we could as well rewrite this to be minus y. Alright, therefore, writing the differential equation for this would be d squared y over dx squared is equal to minus y. Alright, if we should add y to both sides, we would have d squared y over dx squared plus y is equal to 0. Alright, we have formed this differential equation and this is our answer. Okay, we have a second question. Y is equal to x plus a over x. Alright, so we are going to form this differential equation. And remember, I said we are going to differentiate this equation based on the number of constants. We have one constant here, which is constant a. Alright, so we are going to differentiate this equation once. So we would have dy dx is equal to 1 plus, alright, a over x squared, which is 1 minus a over x squared. Alright, you know that if this can as well be rewritten as a plus x minus 1 bracket a. So if we should take the derivative of this, it's going to be 1 minus x minus 2 over a. Alright, so it will then be 1 minus a over x squared. Alright, this is how we got this. Alright, from our first equation, we can make a subject of the formula. So we would have y minus x is equal to a over x. So a would equal to x, y minus x. Alright, we are going to substitute this value of a into this equation. Doing so, we would have dy dx is equal to 1 minus x bracket y minus x over x squared. Alright, so x would cancel x. We would be left with dy dx is equal to 1 minus y minus x all over x. Alright, so here, giving it a common denominator, we would have x minus y plus x. Alright, so let me make some space. Alright, so we would have dy dx is equal to 2x minus y all over x. Alright, so we would multiply both sides by x. So we would have x dy dx is equal to 2x minus y. This is the differential equation of this. Alright, this would be the differential equation. You can as well go ahead to put all of them to the left side, alright, so that we can equate it to 0. Okay, if we should do that, we would have x dy dx minus 2x plus y equal to 0. Alright, this is the differential equation. All right. Lastly or thirdly, we would look at y equal to ax e raised to power x. Okay, we are going to form the differential equation of this exponential equation. This is an exponential equation. So we would be forming its differential equation. How do we do that? First step, we take the derivative of this equation once because we just have one arbitrary constant. All right. But then how do we go about differentiating this equation? Looking at this equation, we know that we are going to apply the product rule. That is why I mentioned earlier in this video that you should know differential calculus and integration handy, because you would be applying it most of the times in solving this in these ordinary differential equation problems. All right. So we would call our x our u, and we would call our exponential x our v. All right. And the product rule is given by v du plus u dv. All right. So if we should call our x u, du is equal to 1 and dv is as well e to the x. All right. So taking the derivative of this equation, we are going to have y is equal to a is a constant, so we could just bring it out. V is e to the x, right? And du is 1, okay? Plus u is x, and dv is also e to the x. All right. So this is basically what we have. But then from this first equation, we can make a subject of the formula. So a from the first equation would equal y over x e to the x. All right. We are going to substitute it into this equation here. We're going to substitute it into this equation here and go ahead with our solving. All right. So we would have y. All right. Sorry, this is dy dx. Okay, don't forget this is dy dx, actually, because this is the derivative of this equation. So we are going to have y over x e to the x, right? Bracket e to the x plus x e to the x. All right, I would have to create more space. So all right. So all right. So if we should expand this, we would have that dy dx is equal to y over x e to the x. All right, e to the x plus y over x e to the x. All right, x e to the x. All right. All right. So we know that this would cancel and this would cancel. All right. So we would be left with dy dx is equal to y over x. All right. Plus y. All right. So we would have y plus xy. All right. So let me make more space here. All right. So we would cross multiply. We are going to have x dy dx is equal to y plus xy. All right. So we could factorize the right hand side of the equation. We are going to have x dy dx is equal to y bracket x plus 1. All right. So this is the differential equation of that exponential equation. You can still go ahead and bring everything to the left side. If we do so, we are going to have like so, x dy dx minus, all right, so we'll put everything here, y bracket x plus 1 is equal to 0, all right. You could as well expand it, or rather distribute the negative. If you distribute the negative sign, we are going to have x dy dx minus yx, all right, minus 1 equal to 0. So this becomes your final differential equation, all right. So finally, this is the differential equation. Okay, so basically we have covered the introduction to a differential equation, all right. We looked at the definition. We also looked at the order, okay. And I failed to note the degree of a differential equation is given by the power of the highest derivative, all right. So here, the degree of this order, the degree of this ODE is 1. It is 1, all right. The degree of this ODE is 1. Why? Because the power of the highest derivative is 1. We only have one derivative here, all right. So if we had let's say x d squared y over dx squared all to the power of 2, all right, minus yx equal to 0, it's going to be a degree of 2, all right, because the degree is given by the power of the highest derivative. So basically, this was the scope of this video. In my subsequent videos in this series of